Hey guys, chapter 5 video here for you today. So our topic is 5.1 and we are going to work on what math vocabulary do I need to understand for this unit. And we have a lot of vocabulary words. We have a lot of words in math and some of them mean lots of different things. So it takes some practice to kind of get used to them. So for your notes today, make sure you write down the date and set up your essential question and topic, and we're going to kind of dive into what these vocab words are. So starting with the word ratio, chapter 5 in our textbook, if you use the same book as us in class, is all focused on ratios. And a ratio is just when you're comparing two quantities. That's all it is. It's a comparison of two quantities. So it's when you're comparing two things. An easy example of writing a ratio is putting it in a fraction format. So 3/4 is a ratio. You're comparing 3 to 4. Other ways you could write that is you could say 3 to 4 with a colon in the middle. Or you could say literally 3 to 4. But really, all of those ways of writing it is the same thing. Those are all ratios. 3/4, 3 to 4, 3 to 4. That's all different ways of doing the same thing. So a ratio is just when you're comparing two quantities. You have these two numbers that you're comparing. But there's special types of ratios that are called rates. Now a rate is a ratio that represents speed. So a rate means speed. I always say in class, rate means speed. Rate, speed, they're the same thing. It's how fast something is happening. So like if I told you I'm going 60 miles in 5 hours, that is a speed. That's telling you how far and how long it'll take me to go there. So that's how fast I am. And then there's a special type of rate called a unit rate. It's also a speed, but it's a special ratio with a denominator of 1. So it's when I tell you my speed with a denominator of 1, like 30 feet in 1 second. That's a unit rate because 1 second is in the denominator. Or you could say 30 feet per second. So unit rates are when you have 1 in the denominator, and a rate just means speed. All right, so let's get into an example. Have you ever been to Chicago before? This is how they get around in Chicago. This is called the L. Kind of similar to like in Seattle, we have the monorail or we have the light rail, but this is how a good way to get around. So we're going to look at this subway car here. There are 45 males and 60 females in a subway car, and the subway car travels 2.5 miles in 5 minutes. Well, there's not a question buried in this problem yet, but what we can do is we can start writing some ratios and rates. So that's what we're going to do. So first off, the male to female ratio. So someone has gone in to the subway car and counted how many guys are there, how many girls are there. And they found out there are 45 males for every 60 females. That's a ratio. You can even simplify that down to 3/4 if you divide that down. So the ratio of males to females is 3 to 4, meaning every time there are 3 guys on this subway car, there are 4 girls. All right, so that's our ratio. Now, we know the subway car can go 2.5 miles in 5 minutes. Well, that's the speed of the car, and we call that the rate. But if I wanted to make it a unit rate, I could divide it by 5. Dividing by 5 is going to give me a denominator of what? Well, 5 divided by 5 is 1. 2.5 divided by 5 is 0.5. So the unit rate for this subway car is it can go 0.5 miles in 1 minute. So half a mile in a minute. That's the speed of the subway car. The speed is 0.5 miles per minute. So what do we have here? Well, we haven't solved anything, but we've written out a lot. So we have a ratio. 3/4 is a ratio. We've got a rate. 2.5 miles in 5 minutes, that's a speed, that's a rate. And then we have a unit rate, 0.5 miles in 1 minute. So all of these are different ways of describing what's going on in this subway car. The ratio, the rate, and the unit rate. Okay, let's try another example, example 2. So we're going to draw a table in our notes, and you might need to pause the video so you can write all of this down. There are 2 things in our table, the amount of square feet and the cost in dollars. Now picture a foot. A foot is like, 12 inches. Square feet means you have a square that's a foot by foot. And what we're measuring is artificial turf. So if you've ever played soccer or football and been out on one of these artificial turfs, they're pretty expensive to put in. And the way they actually work is they actually roll out this fake artificial grass, but it costs money. It costs money. So every square foot that gets rolled out costs dollars. And so our table goes 25 square feet, 100 square feet, 400, and then 1,600. And the cost for that amount of turf is $100, $400, $1,600, and $6,400 just to put down fake grass. Okay, so let's make a ratio out of this. Dollars and amount are what we're measuring. So for instance, it costs $100 for 25 square feet of this grass, this fake grass. So I'm going to write that, $100 for 25 feet squared. And right now it's a ratio, but if I divide it by 25, what would I get in my denominator? 25 divided by 25 would give me a 1, a unit rate. So it's 4 over 1, meaning it's $4 for 1 square foot of grass. So that gives me that unit cost of how much the grass costs. For every square foot, I'm going to pay $4. All right, so the unit rate is $4 per square foot. Okay, another example. Have you seen this before? This is our International Space Station. It's pretty cool. It's up orbiting Earth as we speak, as I'm making this video. And there's one of the scientists inside looking down on Earth. Cool view, huh? So the International Space Station, tell you a little bit about it. There it is again. That's a really cool picture. So it is 249 miles above Earth, orbiting us. And it launched in November 1998. So it's been up there since 1998. And it costs 150 billion United States dollars to get it up there and build it and put it up there. $150 billion. And basically what it's doing is it's just circling the Earth. And it's this space environment where we send scientists and engineers up to test and run different labs and try experiments. They're testing things in biology, they're doing physics, they're doing astronomy, meteorology, they're looking at weather, they're doing all sorts of stuff. So it's basically a giant floating science lab. And it's international because it's not just Americans that fly up to it, but we have people from all different countries and scientists that fly up, and they'll live on this thing for like maybe 6 months or a year at a time, performing their different experiments. So here's our example 3. Why am I showing you all this? Well, below is a table that shows the distance the International Space Station travels while orbiting the Earth. And we're going to find the speed in miles per second. So we're going to study this table. So maybe pause your device and copy some of this information down so I don't go too fast. Okay, so we've got a table with time in seconds and distance in miles. So in 3 seconds, the distance that the International Space Station could go is 14.4 miles. Wow, 3 seconds it goes 14.4 miles. That's amazing. In 6 seconds, it goes 28.8 miles. Wow. Okay, so and then 9 seconds and then 12 seconds. All right, well, we're going to make a ratio of the miles per second. So it can go 14.4 miles in 3 seconds. That's its speed, that's its rate. But let's make that a unit rate so that there's a 1 in the denominator. So we're going to divide by 3 because 3 divided by 3 will give us 1 in the denominator. Now you got to grab a calculator. You got to type in 14.4 divided by 3 and you get 4.8. And on bottom you get 1 like we wanted. So 4.8 miles in 1 second is the unit rate for the International Space Station. That's amazing. In a single second it can travel 4.8 miles. Wow. So I'm going to box that up and label it. That's our unit rate for this problem. So the International Space Station, ISS, International Space Station, the ISS orbits the Earth at a rate of 4.8 miles per second. That is super fast. Okay, one more example. Example 4. We're going to find the unit rate. And we're going to do 2 questions this time. There's going to be like an A and a B. So give yourself some space in your notes for 2 problems. And we'll start on A first. Let's say something can move 220 miles in 4 hours. Well, that's how fast it goes. That's already a rate, 220 miles in 4 hours. But we want the unit rate. So what do we have to divide it by to get a unit rate? Well, we want 1 in the denominator, so we got to divide by what? Oh, we got to divide by 4, because 4 divided by 4 is 1. That'll give us 1 on the bottom of our fraction. So we grab a calculator, we type in 220 divided by 4, and we get 55. So our unit rate is 55 miles in 1 hour. That's our unit rate, 55 miles in 1 hour. I'm going to box that up and label it unit rate. Okay, let's look at the next one. Oh, it costs at the store $14 for 8 apples. All right, 14 over 8. But I want the unit rate. How much does just one apple cost? So what do I got to divide by to get that unit rate? Well, I got to divide by 8. 8 divided by 8 is 1. Then I'm probably going to just use my calculator to do 14 divided by 8. And look, I got 1.75, which makes sense. That means it is $1.75 for one apple. There's our unit rate, $1.75 per apple. Wow. Yeah, apples get expensive after a while. Okay, so example 5. Do you like to drink Mountain Dew? Are you a Mountain Dew drinker? Because we're going to do a Mountain Dew problem. And here's what I know about Mountain Dew. When you buy it at the store, you can get different sized bottles and cans. This is one of those 2-liter bottles, and the store is having a sale today. It is $1.99 to buy a 2-liter bottle of Mountain Dew. All right, but you're having your friends over to your house, and you're going to need more than just one bottle of Mountain Dew. You're going to need a few. So our ratio is it's $1.99 for 2 liters. But you want to buy 7 bottles because you've got a bunch of people coming over and you're throwing a party. So what we're going to do is we're going to multiply 7 times $1.99. And we can do that in our calculator. 7 times $1.99 is 13.93. So it will cost you $13.93 to get your 7 bottles of Mountain Dew. And 7 bottles, if they're 2 liters, is 7 times 2. That's 14 liters of Mountain Dew. You must have a lot of friends coming over to drink that much. 14 liters, wow. Okay, guys, so let's just do a quick summary to kind of wrap up this video here. So we're working on 3 vocabulary words: ratio, rate, and unit rate. And they're all very similar. A ratio example would be like, I'm cooking and my recipe, I'm needing 3 cups of sugar for every 2 eggs. That's a ratio. It's just a relationship between 2 quantities. So if I'm cooking, it's a really easy example. Oh, every time I use 2 eggs, I got to use 3 cups of sugar so my cookies turn out right. A rate is a speed. It's how fast you can do something. So like if I figured out I could read 20 pages in 5 minutes, I time myself. That's how fast I am reading. That's a speed. A unit rate is a special speed that has 1 in the denominator. So like if I said I can drive 60 miles per hour, that's 1 hour. That's a unit rate. All of them are fractions. 3 cups of sugar for 2 eggs is 3 over 2. 20 pages in 5 minutes is 20 over 5. 60 miles per hour is 60 over 1. They're all fractions. So ratio, rate, unit rate, they can all be written as a fraction. But the key thing here is ratio just compares quantities. Rate means you're actually talking about how fast something happens. And unit rate is how fast something happens with 1 in the denominator. Okay guys, that's going to wrap up this big video. I hope you're able to kind of follow along, and we will practice this a lot in class and we'll get better and better at it. Thanks for watching. Bye guys.